Hi everyone, thanks for joining. Today is day number 7. Today we'll move ahead and we are going to learn more about SD-WAN configuration and templates. What I have done yesterday, our old lab that we have built, once I upgraded to 17.0, then both the data plane and control plane came up. So yesterday you have seen that VBond and VS Smart were showing 1.1. Once I have done all the CSR and CRT configuration for vEdge, then it was also showing 1, means everything was up and running, but you have to upgrade that. Now, if you refer this particular blog, this blog also, if you go carefully in the bottom, it will tell you that once you upgrade all the controllers, then only you will see that you can see these numbers. So do everything, whatever steps we have done. Now you have to upgrade that. Okay. So then you can see vEdge can join the control plane. Okay. Upgrade process also we have recorded yesterday. You can follow that. Now today, while I was doing some other thing, I thought of bringing up the controller one more time. But while bringing up the V Smart, I can see here that it is throwing error. You can see it is throwing error. And in one case, you can see it is not taking the system IP. System IP, it is taking 000. Okay, so this is not correct. Now, in case that you are bringing up your fabric and you are seeing that some sort of certificate error or some issue, how you will go and troubleshoot? Okay, so the first thing is this, that your controller should be reachable. Okay, now if you have any certificate issue, you can go to the, what is that, clear? Do have we have clear? No, we don't have. So just a second. So what you can do, that you can go and check, so certificate installed. You can see that certificate is not installed here. First of all, obviously certificate error or something. Second thing, you can go and check your IP reachability. So all your controllers, we know that we have our vManage whose IP is 31, and you know that you have your vBond whose IP is 33. It should be reachable. Then you can go and check your system configuration. Do you have correct vBond IP here? Do you have correct organization names? These parameters, these 4 or 5 parameters that we have discussed. So here you can see that we have all these information correct, but still, if you go back to the dashboard, still you can see that certificate error, these are showing 00, this is showing 11, etc. Right? So I'll come back to this one. Before going there, what you can do, you can go to the configuration, click certificate, go to the controllers. Once you are inside the controller, simply click here and do invalidate. Now, if you do invalidate, okay, then you can see here that this will go. We go to the devices, because what I just wanted to remove this particular device here. Some certificate issue was there. So I can go back here, I can click here, invalidate. Once you click invalidate, you can see this will permanently remove the device and all the control connection. It's quite strange that, oops, after doing invalidate, not removing. It may be some sort of a stale here, but yeah, once you click invalidate, it should go. from here. Let me click refresh. Maybe I have my VPN connection. Let me go and disconnect. Just hold on. VPN connection is, yeah, gone. So if you go click here, invalidate, it should remove unknown error. Let me refresh my page and let's go to the certificate controllers. You can see it was removed, but it was not showing removed here. You can see now you have only vmanage and vbond, right? Now next, what you want, you simply go and want to add that device. So you can go and add the VSmart. And what I have done, that I created, means I spin up one more VSmart whose name is VSmart2 and whose IP is 38, 10, 10, 10, 100, 38. So I just wanted to add this new VSmart whose IP is 172.10.138, and okay. So now you can see that it has been added. Now you can see the system IP. Now you can see the rest of things. You can go to the certificate controller. CSR has been generated. View the CSR. Same thing that we used to do earlier. So I can go here to the shell and I can generate the, uh, we can go and put the CSR. From this CSR, what we are doing generally, oops, let me quit, or okay, no problem. Let me go and write this. I'll go and create 2.csr. Let me put the file here. So my new CSR file is 2.csr. From that, we'll go and generate the CRT. Same thing we used to do, right? So I have 2.csr. From there, I want to generate 2.crt, right? We should have root keys there. So we'll go and use this particular command in the shell. And once you have 2.crt, copy that and install it. Same thing we have done 2-3 times in the back in our previous sessions. Close this, go to install certificate, put here, install. Pushing this list to device 111 vmanage. Okay, failure. Error, root CA unable to generate, invalidate serial number. Some serial number it is generating is invalid. Go to certificate. Sometimes it will show you failure, but don't worry about that. Maybe give this particular device maybe 30 minutes or 40 minutes. It will auto come, means automatically it will come. Okay. Suppose in case you will face this issue 1 or 2, 3 times, then again try to copy and paste your root CA key, then root CA dot key, and then root CA dot pim. Regenerate that CSR, create that new certificate, put here. Do it 1 or 2 times. Suppose still you will get this error. Okay, then you do one thing. You just go to your VMware machine. Um, remove those VMs, restart your VM, and then do it. But that will be your last option. First, give him some time, like 30 minutes or 1 hour, not doing. Then regenerate the key, still not working. Then do that third step. Okay. Once you create your fabric, right? So once you have your fabric up and running, then you have option, right? You can take a snapshot So once you take the snapshot, you somewhere will find that option related to snapshot. See, the snapshot is there. Take the snapshot. Okay, whenever you're creating some policy, doing some major changes, take the snapshot, save that snapshot. Okay, up to a control policy hub and a spoke, up to control policy service insertion, up to control policy multi topology, like that. You know, save it. Once you go in snapshot, once you start this snapshot, your instance will come from there. Okay, so at the moment, I just wanted to give this lab some time. But anyways, what I will do once I have all the lab up and running, I will take the snapshot, and in future classes, I will show you that. See, I have the snapshot that is working one. Now I'm using that. Okay, any question in this? All right, if no question, then we are going to continue this. Meanwhile, it is running in the back. Give him maybe 30 minutes, you'll see that it may work. Otherwise, I'll go and regenerate the CSR after 30-40 minutes, and then we'll see how things will happen. Okay.
Yeah, Ratnesh, I have one question here.
Mm-hmm.
This VM is installed in the on-prem, right?
On-prem, yes.
Yeah. So the same step we need to follow if we are going to install on the cloud.
Yes.
Okay, got it.
And I told you some changes are there, and that change you'll find in this particular section in this blog. I'll come to this. I will explain you about PNP. This is PNP portal, how things are working inside PNP portal. I will come to that after maybe 5-6 class. Once you have little bit knowledge about SD-WAN, I'll come back to this and I'll cover this. You will get clear picture how SD-WAN is working, why it is, what component, everything you will come to know. More than whatever generally people know about SD-WAN. You will know more than that. Okay, great.
Sure, thank you.
So let's continue our class, and we are now you will understand all these slides and all. So how the certification is happening behind the scene, how they are forming this tunnels and all. One thing that you will not understand 100% at this point of time is that how these devices they are building their IPsec tunnel. Do not worry, we will understand this uh, in upcoming session. So what is happening here that once you go and build your control connection. So suppose I have my controllers, suppose these pink ones are my controllers, we manage, we bond, we smart, and then I'll take some rectangles here in the bottom. Those are my edge devices. So I have two edge devices in the bottom. Now, this is very important question. Someone may ask you in the interview that when you are forming the control connections, so control connections, they will form obviously with the controllers, and from controller to edge devices, what type of connection we have? The connection that we have is either DTLS or TLS, right? But these edge devices within themselves, they are always forming IPsec connection, IPsec tunnels. What type of IPsec tunnel? What are the packet exchange inside IPsec tunnels? You will come to know. When we'll go deep inside these tunnels, you will understand these IPsec tunnels, what are the attributes we have inside these IPsec tunnel. At the moment over your screen, you can see that these IPsec tunnels, they have encryption standard, that is AES 256, that is nothing but advanced encryption standard. They have some sort of ESP is nothing but encapsulating security payload. Generally, if you know how this IPsec is working, two different type of headers are there. in the packet. So how it is working, you know that you may have normal data. You want to send that normal data from one place to other place, but before sending that data, you used to do some sort of encapsulation. So you are doing some encapsulation, means you are changing the headers, you are doing some encapsulation, and then you are sending that data from one place to other place. Now whatever place you are sending that data, that, so from here the data packet will come to edge 1. It will do all sort of encapsulation. Inside that encapsulation, different type of headers are there. So here you can see that ESP, encapsulating security payload, not only the encryption or decryption is standard, but there are hashing, there are different type of cryptographic standards are there. We can discuss that later on. So in very loose term, your packet, you are doing some sort of encapsulation while you are sending. And from which interface you are sending? Question to everyone. From which interface you are sending the data?
Yeah, from the T-lock.
VPN
It
0
is
interface.
VPN. Yeah,
VPN
VPN
0.
zero.
Yeah,
Yeah.
yeah, that's T-lock. That's 100% right. T-lock is nothing but your gateway. It has some
Yeah.
attribute. We'll see that. But from VPN 0, we are doing our encapsulation VPN 0. So from VPN 0 this side to other side VPN 0, you have some sort of IPsec tunnel in between over any transport, either it's MPLS or broadband, any type of transport. As long as you have IP reachability, you can send that data. Once the data packet will come here, then it will do the decapsulation for that. Okay. And then it will send that data to the destination. Now it's normal IPsec that we are considering here with one small change here. There is one small change. If you go and check that particular header, you'll find in that header you have room for tag as well. Tag is nothing but your VPN. So whenever you're writing VPN 10, 20, 30, whatever, these VPNs, these numbers are nothing but VRF, virtual routing forwarding instances, but they are very much like MPLS tag switching or MPLS label switching. These are some numbers you are putting inside this, and when it is reaching here at this point, so it will see this is for VRF or VPN 10, or is this for VPN or VRF 20, or is this for VPN or VRF 30. And that's why in the diagram itself you can see that we have three different type of pipe. This, see, we have one big pipe, right? That is nothing but IPsec framework. Inside that, you have different type of tagging for different VRF or VPN. So that means that suppose VPN 10 wants to send data to other side VPN 10, he is allowed to send that data just to VPN 10 until unless you do some sort of route leaking. Okay, until unless you do some sort of inter VRF communication. So you can do some sort of route leaking or route import export, whatever name you can tell. So I want to send some route from VPN 10 to VPN 20. Either it's the same device or any device in the fabric. Until unless you do some sort of route leaking or route redistribution within the VRF, it will not work. Okay, that much power, that much capability this VPN, this SD-WAN fabric is giving to you. And this route leaking or route import export, what's the technology name for that? You know that? The technical name for that?
Yeah, that is for the VRF, right? Means
That
in
is
the
called
VRF
segmentation.
segmentation. Yeah,
Yeah,
segmentation of VRF.
that's the technology, segmentation.
Segmentation.
Yeah.
Yeah, correct.
So
So it will allow us to segregate the traffic from the one point to the another point.
yeah, yeah, 100%
And
right.
I have two, three questions here.
Yes,
Okay.
yes, please ask.
So, what type of the connection we are forming between the vBond and the vSmart and from the vSmart to the vManage? Okay. And second question is here, how the VLAN traffic means, sorry, how the LAN traffic is going to map over the this VPN 0? Because as I know that the this WAN side VPN is always 0, that is a dedicated VPN, and the management VPN is 512. And whatever the VPN that is coming between the 0 to 512 means from the 1 to 511, that is used for the LAN traffic. So how this LAN traffic, because we are going for the segmentation, means it is not overlapping the LAN side traffic over the this VPN 0. So we need any media to reach from the source to destination, right? So how this traffic is going to mapping from the VPN 1 to VPN 0 to carry the traffic?
Okay, I'll answer that. I will repeat your question and I'll answer that. Just hold on. Let me open one slide where I have that answer. Let me quickly check. Yeah. Okay, so this is our last slide for today's class because it will take at least 1 hour to understand. Only this slide. Okay, so be ready. And if you want to draw something in your notebook, in your copy, you can do that. And let me turn on my AC as well so I will not face heat while explaining this slide. All right, I'm going to answer most of your questions now, although at this point of time, you don't know about OMP, you don't know about TLOC. But I will make this little bit easier. You will understand the OMP, you will understand the TLOC. It's not a very new term. OMP is nothing but overlay management protocol. It's a routing type of protocol. And TLOC is just the next hop. Although I have multiple slides to explain OMP and TLOCs, so don't worry if you do not understand today. In coming 4 or 5 days, you'll understand more and more about OMP and TLOC. So this is your fabric protocol. This is your overlay protocol, and how the traffic will move to next hop. In networking, always you try to look for next hop. Next hop. If you are not able to reach to next hop, you will not reach to destination. So this is nothing but your gateway from where you are entering inside WAN. Okay. Now I will go and tell you what question that Sanjay is asking. That's obvious. So he's asking, okay, we have different type of VPN, right? At this point of time, I will take only one VPN. So for example, I have VPN 10. Now this VPN 10, and you should also argue this thing. Let me go back one slide. So I'll try to, okay, this is perfect. So here you can see this particular diagram. In this diagram, you can see clearly that you have VPN 0, where it is going? WAN. This is what? Your WAN facing interface, right? Where you are connecting your carrier providers like MPLS, internet, etc. And here you can see this is loosely, it's like untrusted zone. So you just want to put some sort of firewall or something, some rule, some access rule, etc., etc., while going outside, or maybe from here while coming inside, right? We'll discuss that design part later. But this is your untouched zone. Now then you have something called your VRF or VPN, where what you will connect? You will go and connect your switches, L3 switches, or core routers, or L3 core switches. Means you want to do core routing for your LAN infrastructure, right? So not only the LAN, but you can go and connect some third-party routers as well. Third-party routers means if you have some company merger, or if you have some sort of you have regions and site, so multiple sites are connecting at one place. So here you are running OSPF, other place you are running some sort of EIGRP or BGP, that thing also. So it is not only for LAN. I just wanted to tell this. It may be there for site migration or other reasons as well. Okay, at the moment, let's take one step back. It's for LAN. So one interface is for WAN, for sake of simplicity. One interface is for LAN, and then other interface is our out of band management. Just we want to send or receive SSH or maybe SNMP or such type of management related traffic. Up to this point, any doubt?
No.
No,
Okay.
no, no.
No. So now question here is this, that I may have VPN 10, 20, 30, 40. How it will come here, and then how it will get encapsulated, reach to destination, and same type of setup you have here as well. So that means here you have one of your router. So how it will reach, how VPN 10 traffic will reach here, and then how it will go to VPN 10 only. Because remember I told you VPN 10 will go only to VPN 10 until unless we do something. And if everything is done by these controllers, then what is the use of VSmart? Okay. So now you have to think little bit three dimension. So from VSmart to S device, at the moment, forget about vManage and forget about vWAN. Just think about VSmart is your control plane. Who is your control plane? VSmart. VSmart is your controller. This is your control plane. Okay. So from VSmart to edge devices, we have something called OMP, Overlay Management Protocol. Okay. Now, if you have two VH devices, they do not have OMP in between them. Edge devices always have OMP pair with VSmart. Okay. So what's the meaning of this? VSmart is your brain. He knows all the routes inside the SD-WAN fabric, and then you are pairing with VSmart as OMP peer. Okay, VSmart is your OMP peer. VSmart is your OMP peer. Right now, what type of packets we are sending, receiving inside OMP? No brainer. Routing update, some IPsec key exchange. Remember, this is working as a key server as well. So suppose if these two devices, device A and device B, they want to form IPsec tunnel, what are the things they need? If you go and read this IPsec tunnel, you'll find that they are doing some sort of phase 1 and phase 2 key negotiation. Okay, and since you are not knowing who is your routing destination, you will ask this question to whom? You will ask this thing to VSmart. Hey VSmart, um, you are my parent. Tell me with how many devices I have to form IPsec tunnel. Give me that reachability. Give me that information. So VSmart first of all will give you routing information, how to reach to this. Now you can reach to this device, but still you need some sort of key. So then again you will ask VSmart, can you give me the key? I want to form IPsec tunnel. Again, you will understand more about this T-lock information, what is there in T-lock, and OMP and T-lock, they are working hand in hand. And I'm going to show you this in the next slide, that how OMP is relying upon T-lock and what are the informations we have, sorry, T-lock, TLOC, transport locators. Okay. So how OMP and T-Lock, they are working hand in hand to form the IPsec tunnel in between that. Now, once you are forming the IPsec tunnel, remember the previous slide I told you, this IPsec framework that they are forming, they are just the framework. But within this framework, you may have VPN 10, you may have VPN 20, you may have VPN 30. So that means internally these VPNs, they are doing some sort of communication that they are telling VPN 0 about their label. See, this is the packet. So how the packet will come? Any packet will come, any IP routing packet will come. They are coming with label 10. Now this same label will come to VPN 0 because VPN 0 is the gateway, means from here the packet will leave. And at the VPN 0, you have system IP, site ID. We'll see that what informations it has. Okay, it has the next hop information. You think like T-Lock. He has the T-Lock information. Who is my next hop? I'm going to show you this in the next slide. So this packet is coming with label 10 VPN. This VRF, they are not VPN actually. This is a misleading term. They are the VRF. So these routing update, they are coming from VRF 10 or label 10 going to VPN 0. VPN 0 is just the transport. He will send that to other side router, and this other side router, he has to decide, oh, this level is for VPN 10, send to VPN 10 destination. This level is for VPN 20, send to VPN 20 location, etc. Okay, so roughly you will understand in this that if two devices are there, they are forming their IPsec tunnel with help of VSmart. They are doing their routing HMS. They are learning the routes. They are learning actually their T-locks with this VSmart. VSmart is working as a route reflector. VSmart is working as a key server. He has to do all this manipulation. Then they are forming the IPsec tunnel. Now, once you have that IPsec tunnel, that is nothing but a big pipe. Inside that, you have multiple label forwarding. You know, global table, global routing table, and then you have VRF table. So you have this global framework. Inside that, you can pass VPN 10, 20, 30. That will purely happening as in terms of label. So label will preserved here at this end, and then it will be decapsulated at this end. In between, your traffic is encrypted. It's secure. Sanjay, this is not
Yeah,
your full answer, but you will
yeah.
understand.
Actually, what I'm asking here, uh, there is a vSmart and there is the two edge devices at the site or maybe the different site. So vSmart is always working as a route reflector, right?
Yeah.
So whatever the routes is coming from the one edge devices, it is coming to the vSmart and it is coming over the OMP protocols. Means it is just like as a working as a, you can say at the BGP, right? The WAN
Yes.
protocols.
It's a
So
BGP.
it is, yeah. So OMP is basically carrying the three types of the routes. That is the big tailor routes,
We will
service
check
route.
that. Yeah, we'll check
Yes,
that
yes,
later
yes.
on.
Yeah,
Yes.
yeah.
These three. Yeah.
So that is the big tailor routes and service routes, and there is the another TLOC information. And this TLOC information having the system IP encapsulation and the color, right?
Yeah.
So this information is going over the OMP tunnels, OMP protocols, and reach to the vSmart. So vSmart is knows about the information about the one VS devices, and they're taking the decision on the basis of the TLOC information, as I know, because it is having the system IP, color, and the encapsulation, and passing the same information to the other VH. And including this information, it is also forwarding the key information to the vSmart. And this key information is also shared with this another VH to forming the IPsec tunnel between the two VS devices. Am I
That
right?
is 100% correct statement. Yep.
Yeah.
And
So,
let's go to next slide and then we'll conclude this. Okay. Do
okay,
not
okay, sure,
make
sure.
summary. Let's try to
Okay, okay,
understand
understood.
this. And I have animation
My
slide.
question is only here that means there is the segmentation of the traffic means VPN, whatever the VPN 10 LAN traffic and the VPN means, is there any configuration is required or it is by default it is going and carry over the WAN, that is the VPN 0, the WAN side traffic?
Configuration is obviously required if you want to restrict something,
Okay.
or if you want to allow also something, it is required. So suppose VPN 10 by default will not talk to VPN 20. So you need to do configuration, you need to go create data policy. So configuration is required. It means we can't leave everything default. Uh, there are control policies, there are data policies. We'll see that. Okay.
Okay.
Configuration is required. By default, it will work. But if you control, that is good strategy if you are controlling that.
So this line side of traffic is automatically switch over to the VPN 0 to carry the line side traffic to the vSmart, or we need any manual configuration to mapping over this VPN 0.
Mm, by default, it is not required. Automatically
So
tunnels will form. It will go.
so inside the one ABH box, the tunnels will create between the VLAN 10 and the this VPN 10 and the VPN 0. Is there any communication? How they will communicate to the VPN 0?
Okay. So you know the concept of VRF, right?
Right, right. VRF is basically used for the segmentation of the traffic. Means it will
Yeah. So
not allow to route the.
this is loosely termed as a VPN. It's not VPN. It's a VRF. The VPN term is not correct in Viptela. It's a VRF. So if we are telling VPN 10, VPN 20, this is the marketing term that Viptela has created. So they don't have individual VPN 10 IPsec, VPN 20 IPsec, VPN 30 IPsec. This is not correct. They are actually VRF 10, VRF 20, VRF 30, and whatever technology we learned long back in Cisco, that how IPsec VRF is working, the same thing is here, little bit automated. So you will see in, again, we are not reached to that point, but you will see that you are not doing any configuration related to IPsec in the Viptela boxes. Still they are forming IPsec because that configuration is behind the scene automated inside the boxes.
Yeah,
Okay.
that is by default automatically forming the IPsec tunnel between the two devices.
Yeah. Why?
Correct.
Because some automation is there behind the scene in the box.
Yeah, understood.
Okay. This is term as a VPN 10, 20, 30, 40. Nowadays it's not even, you
No,
have to
but
create where.
it needs any WAN media to come out from the internet or the MPLS, right? To reach to the vSmart.
So obviously, how you will reach to
Yeah,
VS
so
Smart? It is there
yeah.
in.
So that internal thing I wanted to know means VPN 10 traffic, how it is going to patch into the VPN 0, and then VPN 0 will come to the T-lock and come out to the vSmart.
Okay.
Yeah,
I
that I
was
wanted to
looking.
know.
I was looking for one automation slide I have. Uh, so let me quickly figure out that if it is there. Otherwise, I will explain you manually. You will understand that. But I have an automation slide as well. I'm checking that if it is there, then good. Otherwise, I will explain you. I think it is not there. So let me. This particular diagram that you are seeing here, I have automation for this. It is not here at the moment, but no worries. You will understand what you are asking. So see here, this diagram is very important. We are going to spend a lot of time here now. This is edge device, right? Okay. This edge device having some IP called system IP. This is not routable. Okay. Any doubt in this? Now this particular edge device have one site. Uh, let's take this. They are in site 1 and think like this, that this is VPN 1. You can see VPN 1. This big box that you are seeing here, this big box, see this box here. Okay. In this big box, you'll find that you have this router here as a VPN 0, VRF instances of routing. So I have two VRF here. One VRF is connected to LAN This is my LAN connection. Okay. And one VRF I have that will go to ISP. So you can see that ISP side, I have three different ISP: Internet, MPLS, and 4G, for just for an example. Now these T-locks, what they are carrying? Sanjay, what information we have in T-lock?
Yeah, it is carry the system IP encapsulation and color.
System IP, encapsulation,
And
and
color.
color. Okay. Now here
Mhm.
in the diagram, you can see that you have system IP. You can see color: green, orange, blue. Green for MPLS, orange or maybe yellow for internet, and blue for 4G, right? And then
Correct.
in encapsulation at the moment, let's think only about IPsec. Okay. So how things are happening here inside the box itself, if you go and see, you'll find that your VPN or VRF, this is your source. Think that this is your source. A is my source. And where this A want to reach? A want to reach to somewhere here in the B. So A and B, they wants to communicate. A and B, they are part of, at the moment, think that they are part of same site. I'll go and make this also as a 10. They are part of same site 10, site 10, and they want to reach. Okay. Now here you can see clearly you will understand this, Sanjay. Clearly you can see that VPN1 VPN1 has subnets, right? 10.0.0.0 slash 24, for example. Now this VPN1 prefix information with some registration, you have to do register with VSmart. VSmart will learn, okay? VSmart will learn this prefix how? With help of OMP. Any doubt in this? We are at,
So,
yeah, we are talking
so
only this
this
part.
okay, okay. So this land side traffic, that is the VPN 10
You do not tell
traffic is
VPN 10, you tell VRF.
VRF. Yeah, so
Yes.
VRF is automatically redistributed over the OMP, right?
Yes.
To reach to the
That
vSmart.
configuration is actually nothing is automated. It is automated, but if you check the configuration, the default configuration for VH, you'll find that it is redistributed.
I'm seeing in the diagram here, suppose that
Mhm.
this is a line side traffic and maybe it is a core router or maybe any L3 devices that is coming to the VPN1, right? This is the router symbol you are making here, right? The blue
Yeah.
color. And
A.
then it is binding, yeah.
Yeah.
Yeah, from the A side routes, whatever the routes is pushing by the user, it
Hmm.
is coming to the this VH box, and this is the inside VH box architecture, right?
Yep.
Yeah,
This
so
is
it is
inside the
coming
box.
inside the VH box. Okay, so
Yeah.
this is the VPN1, and this VPN1 is binding and going towards the this vSmart, right?
Yep.
And here is the red color, that is the VPN0 traffic, and it is going to the forming the TLOC information with the ISP, right?
Yep.
So
So,
how this media is going to connect, because it is I'm seeing that it is separately going to the registered update and then reaching to the vSmart, right? It is through the this OMP protocols, right? So what is the role of the TLOC here? Means VPN0 here, because I'm seeing that the traffic is segregating separately and going to the registration update and then the reaching to the vSmart. Then where is the traffic destined to the this VPN0?
okay. So think in twofold. That device is communicating with VSmart, and this device is forming the IPsec tunnel in between. So there are two tunnel. Here you have something called IPsec, and here inside DTLS or TLS tunnel, you have OMP. This is inside DTLS or TLS. Now, two roles are there. So first, you are part of fabric. So first, your responsibility to do the communication with VSmart. So suppose I have one subnet called X. Now this X subnet can reach to VSmart via any media, right? So that media may be Internet MPLS 4G. Now this media, so suppose VSmart is learning about network X. He can learn that network X via three different paths. Those paths are either T1 or T2 or T3. So now VSmart knows that network X I can reach via T1, T2, T3. Okay. Same registration process is happening here as well. Now VSmart knows that I can reach to B via T1, and that T1, T2, T2, T1, T2, T3 is different. This is not the same T1, T2, T3 that you have here. Why? Because here system IP is different. So if system IP is different, that means obviously T-lock will change. Correct?
Yes, yes.
Yeah.
So here you can think that this is T1 dash T1 dash 2 T1 dash 3. So here you have normal T1 T2 T3. Here you have T1 T2 T3 dash 1 2 3, like that you can think. Okay. Now VSmart knows about how we can reach to this, how we can reach to this. But VSmart is not for data traffic. This is just for control traffic. So when you send the actual data from VPN 10 to other side VPN 10, it will not go via the control connection, right? It has to go via media where you have IPsec tunnel. And in previous section, I told you that VSmart is responsible to form the IPsec tunnel, because not only he is exchanging the route, but he is working as a key server as well. Okay, so when you send the data for VPN 10, it will go and bind with VPN 0 internally with the tag switch, because VPN are nothing but VRF. And whatever VRF technology is working, same thing is happening here as well. Okay, so VPN 10 traffic glued with VPN 0, it will go and choose which particular transport I have to reach, because in SD-WAN, any transport, by default, it can go via any TLOC, or it can return via any TLOC, until unless we'll go and put some restriction there. Okay, you can make primary, secondary, tertiary via the configuration. By default, they will do equal load balancing. Okay, so your traffic can go and reach to this, it can come this.
Okay, so this BPN 1 and BPN 0 is internally binding with each other, right?
Yes, 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 yeah. Means this is
Okay.
your global routing table. VPN 0, you think as a global routing table, ZRT.
Okay.
And then you have your VRFs, VRF 10, 20, 30, 40, etc. Now again, suppose here you have 10 and other side you have 20. So you have to go and create some sort of data policy inside VSmart. VSmart has to leak 10 and 20, 20 to 10, and then they will communicate. But this VPN is nothing but VRF. VRF is nothing but label switching. These labels, they are internally binded with these VPN 0. They are glued with this. They are part of same system. Okay.
So this
Ratnesh, I have a
BPN,
question.
Yeah,
yeah,
yeah.
yeah.
Please ask.
I have a couple of questions. So, this VPN one, that box, whatever the binding it is happening with the vSmart. So, apart from the OMP protocol, are they using any kind of VPN, like any VPN 0 is also working there?
VPN 0 is working there, yes, and VPN 0, we'll see that what different type of tables you have. You can go and make three different type of table. You can go and make IPsec table or connection. You can think like this: IPsec connection. You can make OMP connection. You can make DTL STLS connection. You can create NAT table as well. All these tables are separated.
So, between vSmart and this VH, so also VPN 0 is working there, you are saying, right?
Yes, so that OMP is over VPN 0.
Yeah.
Because
Yeah, that
here
was
we
my
have,
understanding.
yeah, So here we have the physical connection. Everything, all the interfaces are part of VPN 0, and one is going to INET, one is going to MPLS, one is going to 4G.
Okay. And this prefix, whatever coming to support prefix VPN 10, coming to VPN 1, whatever mentioned their example, then coming to below VPN 0, how it's like related? Can you explain one more time? VPN
Yeah.
0 is global routing, you understand, but in between VPN 1 is there. So VPN 10 to VPN 1 to VPN 0. How it is
Oh,
like,
here it's not one actually. This is 10. Think this as a VPN
VPN
10.
10, yeah,
Yeah, yeah.
correct. So VPN 10 is coming to your VPN 1.
So any prefix that is part of VPN 10, logically means physically it will go to VPN 0, and then it will go to other side. That's behind the scene.
Between VPN 1, what is the role of VPN 1 then VPN?
Okay, either it's a VPN 1 or VPN 10, doesn't matter. Where you are seeing VPN 1, I have made this
It's
10.
written. Okay. For VPN 10, then
Yeah,
that's fine.
yeah, I have made this VPN 10. So we have VPN 10 everywhere. VPN 10. Here also you have VPN 10.
Okay, that's I got confused. So basically, whatever the prefix is coming right, it is sending to the vSmart with the T-log information, and vSmart is sending to the other side. If it is requesting that side, B side is trying to reach to A, and with that T-log information, that VPN 10 to VPN 10 count is happening over the VPN 0, right?
Yeah, so this is little bit confusing at the moment. So please do not draw any conclusion. But Sanjay, understand that how the things happening behind the scene. I have to cover OMP and T-log. Okay, just wait for that session. You will understand more and more and more in upcoming session. I have nice slides. Okay, just wait for a little bit, and you will understand this how it is working. Okay, you think that you are forming the control connection first. So once you are forming the control connection first, the VSmart knows your prefixes via all the media, via all the VPN 0 connection. Now when you want to send your data will always go via the IPsec tunnel, but that IPsec tunnel you have from end to end. So VPN 0 this side to VPN 0 that side, physical type of connection you have, right? So data will go via that media. You will understand this. Just
And I have idea, Ratnesh.
mhm.
So this connection, IPsec tunnel connection, so it will not happen directly, right? Because side A again will contact the vSmart, right? For fetching those information to reach to the side B. Once that get the information, it will form the tunnel, right, with the help of T-log.
Yes, yep, right.
Oh,
Because T-lock is nothing but the next hop.
next, yeah,
So if you know that from this next hop I can reach to this next hop, that means you have your IP reachability via any media. Next hop to next hop reachability should be there. That means that this device is learning the next hop of this device and vice versa. If you go and remove that learning of next hop, that means they will not form the IPsec. And
correct. That is the thing.
we have lab for that. We have a lab related to hub and a spoke. So in that lab, what will happen? And then I will uh, stop the session. I will take some 10-minute break. So in that lab, what will happen? Suppose you have data center, you have um, two devices in data center, and suppose you have three devices in branch, like that. This type of topology you have. Now, by default, you know what SD-WAN will do, that they will form, oops, sorry for that. By default, the SD-WAN will do that they will form this type of IPsec tunnel, this type of IPsec tunnel. And in between, suppose they are part of same site, the same site will not form the IPsec, right? So this is site 10, and suppose this is site 1 and this is site 2, or maybe both are site 1 1. This type of IPsec tunnel they will form, right? If,
Uh,
yeah,
what
so
you have drawn, you explained one more
nobody
thing. And the
understand,
top
okay.
two are BH.
Okay, let me redraw and let me explain with few
Just
device.
put that.
Okay, let me just give me one second. Okay, see, I'll make this little bit easier. Suppose I have three devices. This is my data center router. This is part of site ID 10. Okay, this is my branch. Suppose this is my branch 1. So BR1. This has site ID 20. Okay, and suppose this is my branch number 2. This has site ID 30. Now, if you go and form the means if you go and bring up the control plane and data plane, what will happen? They will go and form the IPsec tunnel like this. All the devices, they have this green color is IPsec tunnel. All these devices, they have their IPsec connection, right? Any doubt in
Right.
this? This
No,
will
there
form
is
like
a
this. No
yeah, yeah,
problem.
yeah. This yeah, there
They
is a
will
V
go.
smart means each and every information is going to V smart, and then V smart is going to each and
So you
providing the
have your
information. Yeah,
VS Smart, for example,
yeah,
here,
yeah.
and then if I have some other color, so
Each and every DC1 and this branch office is also connected to this V smart. Yeah.
these have some connection, but this connection is what type of connection?
This is the
So
internet means
this
DTLS. It
is
will form.
this is DTLS, this is OMP, right?
OMP,
Yeah.
OMP, yeah.
So you have OMP with your VS Smart. Okay, but they are with VS Smart, they are not doing any data exchange. They are sending their control packets, right? Okay.
Correct, correct.
Correct.
Now suppose your organization will go and tell you that all the branches should send the traffic first to the data center, and then the traffic should go to other data center. Means suppose if your requirement is something like this, that you have to send the traffic to the data center first, and then from that data center it will go to other branch, right? Then how you will do? You don't need this connection, correct? So how you will control that? Then in that case, you have to go to VS Smart and you have to tell VS Smart, do not send the TLOC information. So branch 2, this is branch 2. So do not send the TLOC information of branch 1 to this branch 2, right? From VS Smart, this branch 1, what VS Smart will tell? VS Smart, do not send the TLOC information of branch number 2 to this particular router. So if he don't have TLOC information of this branch, he don't have the information of TLOC for this branch, they will not form the IPsec tunnel. So this is one use case. This is called hub and a spoke. You have your hub and then you have your spoke. A spoke and a spoke, they are not forming their IPsec tunnel directly.
So this is to be done with the help of policy, right? Policy to be
Obviously,
input,
a
huh?
policy, yeah, policy.
Oh,
Okay, so with this particular point, I'm going to pause the recording. Let's take a break. All right. So once you go and bring up your fabric, so your control plane will come up and then your data plane will come up. Once your control and data plane will come up, then obviously your fabric is fully functional. And then you can go and check few of the important parameters. So you can go and check your control connection. You can go and check your IPsec tunnel information. Here one a very important thing is this, that at the moment you'll go and bring your data plane. So these data plane tracking will also get a start. And there is one protocol called BFT, bidirectional forwarding detection, that will go and check end-to-end tunnel health, uh, some sort of delay in between tunnel and all those parameters. This BFT is very, very important. I don't think so. Anyone will go and ask you question related to BFT in interview, because we know that SD-WAN technology, inside SD-WAN technology is doing some sort of app-aware routing, application-aware routing, and for that BFT is one of the key parameter who will give you this flexibility that uh, in case if you are facing latency or slowness in one particular circuit or one direction, then you will uh, redirect it to other circuits or other direction. So this BFT, this use of BFT is huge. You will see when we'll go and learn about application aware routing. One of the toughest lab we have in SD-WAN is application aware routing lab, because you have to understand about the application, their nature. Then you have to go and build different type of policy, like you have to create SLAs, you have to go and create the policy, how it will do the load balancing, etc. Okay, so in that you will understand more and more about that, how behind the scene this BFT is working to detect the loss latency jitter, not only the one way loss latency jitter, but average as well. Okay, we are doing some sort of sampling for the BFTs. So once you have good amount of samples for BFT, on basis of that sample, you'll come to know that what is the average loss latency, okay, during that certain period. So this is actually very important, and we will see that. We have lab for this as well. Okay, some recommendation are there. This recommendation again, uh, you will understand more when we'll go and read about high availability and redundancy. But in the previous sections, we have discussed this little bit, that if you have one vManage can go and handle 2000 routers. So if you have cluster of 3 vManage, then it will go and handle up to 6000 router. Apart from that, the recommendation about vSmart, recommendation about vBond, recommendation about vManage. We will deep dive in all these things in upcoming session, when we'll go and touch high availability and redundancy. Okay, this is just the summary information that you have. We have at least 20 to 25 slides for this.
So, Ratnesh here,
Mhm.
in one cluster, how many vManage we can install?
In one cluster, how many vManage you can install? It depends upon, say, minimum three.
Oh, minimum three, and
Minimum three.
maximum?
Maximum, it depends upon your routers, how many you want to support.
So
Okay.
that means I can't deploy two.
See, there is Cisco policy. What they are telling, if you have less than three controllers in cluster, will not support. You're not able to raise TACs. Even if you're able to raise TACs, then they will tell, okay, will give us best effort support. Yeah, you can have one as well. One, two, three. Okay. So now what we are doing, because still we are in the basics, we are doing our basic session. So you can go and check few of the commands. You can go to log into the NES device. You can go and check the BFD session. You can go and check the control connection. You can go and check control connection, local properties, etc. So I'll go and give you 4 or 5 very important commands: certificate install, etc. Okay, and you need to list out. So we have one cheat sheet. You just understand what this command means, this command means this, etc. All right, so I'm going to log into the Fabric. Let me try to log in, and we will check few of the basic command at this point of time. Okay, so you can see that we are in the Fabric. You can go to check the menu. Inside menu, you can go see monitor. Inside monitor, you have overview, devices, tunnel, etc. So many things. I just wanted to show you devices first. So this is the dashboard, right? Now, good thing about Cisco SD-WAN dashboard is this, that at the moment you are seeing the vManage dashboard. Now from vManage dashboard, you can go inside individual device dashboard. So suppose if I want to see this DC1 VH1 dashboard, you just click there and now you are inside DC1 VH1 dashboard, where you can go and check so many different things. See, you can go and check the applications. You can go and check interface tracker, QS, interface related, tunnel related options are there. And in the bottom, you can check the real time information. You can do some troubleshooting as well. A good amount of informations we have here. Obviously, we'll see more and more when we do the lab. So at the moment, if I go and click real time, and I just wanted to see the BFD information. So simply go search BFD. You can see BFD related commands, BFD session, BFD summary, etc. etc. What I want to see, BFD sessions. And it's loading. It will ask you want to filter, you don't want to filter. At the moment, I don't want to filter. I just wanted to see this. So you can see that I have BFD session, BFD indirectly. You have the IPsec session because where this BFD is running, this BFD is running inside the IPsec tunnel. Oops, I should draw some better. So if I have some, okay, no problem. I can draw like this. So you have your IPsec tunnel, right? And this IPsec tunnel, who is tracking this IPsec tunnel? This tunnel is tracked by some BFD inside that, right? So you have something called BFD going inside this end to end. So if you have 4 BFD sessions, that means you have 4 IPsec tunnel. Okay. So you can go and check all those commands, not all, maybe at least most of the commands that you can go and check via CLI. You can go to this real time, and from the GUI itself also you can go and check. What I will do, I will go and log into this particular device from the GUI itself, and then I'll do the direct SSH as well. So go back to this vManage. Inside vManage dashboard, you can see this tools option. Click to the tools, and then you can see this SSH terminal. Click to that SSH terminal, and then here you can see the list of devices. I want DC1 VH1. So I can click to DC1 VH1, and I'll give username and password admin. Because it's a GUI interface, you can increase the font size. Let me increase this. Control H, maybe increase this. Ah, oops, something is happening there. I think I lost that, but no problem. From there also you can go type the command in the shell, or I can go here and here you can go and create one new folder. Let me create one new VeloCloud lab, and in this lab I can go and add the vManage IP, and then the username and password. Save. Let me try log into vManage. Now once you are inside the vManage, you can go and check show control connections, and you can see that you have so many devices here. Now in this list, I want to log into one of the edge device. This edge device 10101. So from here you can SSH to that particular device. Oops. You can go to shell and then SSH to that particular device. Mhm. Okay, you're inside DC1 VH1, right? We shall clear, and then you can check what show BFT suggestions. The same thing that you are seeing there in the GUI. You can see from here as well. Then you can go and check show control connections. Show control connection, it is telling that what's protocol you are using, what's the local color. You'll understand more about this local color encapsulation obviously in upcoming session. And if you decrease the font size here, so if you have that option, let me check. Like, I want to decrease the font size. Appearance and change, and so you will see all this information in one line. Font size is very small, but you can see everything in one line, this information. So it is telling that, okay, I am in DC1, my peer type is, I am pairing with vsmart, vsmart vmanage. So it is showing you the control connection. So I have control connection with vsmart. You can see the same IP for vsmart twice. Why it is twice? Because it is reaching to vsmart over one transport, other transport. So you can see MPLS and internet, right? So if you go and draw this diagram logically, you will find that you have your DC device, okay, and then you have your vSmart, you have your vManage, you have actually two vSmart here. So you have two vSmarts, and how you are reaching there? You have actually two ISP. So, oops, sorry, in between you have ISP1, ISP2. So here you are reaching like this, and then you are reaching like this. Over which interface you are reaching? You are reaching over obviously VPN 0. So you can see that you have two active connection to reach to vSmart, but interesting thing is there that you will see that to reach to vManage, either you are going via internet or you can go via MPLS. Now, can you change this? Yes, you can do some configuration change. And if you want to reach to vmanage via MPLS, because you have two options, then obviously you can go and reach. Now, what will happen? Suppose if any problem in there, automatically it will go and reach via other transport. So if I go to VPN 0 and disable this internet interface inside VPN 0, you will see that it will form the vManage connection via the MPLS. Okay, so in case of vSmart, you have active connection, but in case of vManage, you have active and a standby connection. This is one of the key feature we have. Great. Now, this is not it that they are forming some OMP connection or DTLS or etc. There are some other things as well behind the scene, and you will understand that later. Behind the scene thing is this, that let me try to draw, and you can go and create your memory map. So suppose I have one device here, and suppose I will take only one vManage and one vSmart. So this is nothing but, oops, second. So this is nothing but my vManage, and this is nothing but my vSmart, and this is my VH, for example, I will come to know that vManage is pushing the configuration with one other protocol called netconf. Although you have control connection, but while pushing the template, they are using some other mechanism. So he will go and use netconf. But when VSmart will push anything, any policy, any configuration, any key exchange, he will use OMP protocol. Okay, you will understand this also. In these things are there in our slides, so don't worry. All
Yeah,
right,
Radha.
yeah, these things are there in our slides, so don't worry. These things are there. You will understand. Yeah. So three command I just wanted to show you. You want to check the control connection. You want to check the BFT. You want to check your IPsec inbound. Its font is very small. I'm going to increase that. IPsec inbound outward connection. Right? You want to check your BFT session. I'm giving you only 4 commands at this moment. I will ask you in next class. Show control connections. I will put these commands here in the chat window as well. Show control local properties. Show certificate installed. Show history. So what command we have used? Okay, let me put this in the chat window. Please note these few commands. They are a very useful command. BFT session, control connection, IPsec inbound outbound, BFT local property certificate installed. Okay, so uh, this is our last slide for today. These three slides, and then
Radha,
yeah,
go back to that CLI from and run that show control connection that from this. So here if you draw last time, right, two V smart. So the side 80, 10 and 20, can you draw like which part this is covering? Just kind of code it into the diagram.
okay,
So that concept will be clear.
okay, all right. So site ID you're telling.
Yeah, first two are 10 and 20. These are which part side ID? If you draw the diagram
VS
next time.
Smart, VS Smart site ID.
So first two V smart are with the side ID. First he said V smart with side ID 10 and
10.
second V smart with side ID 20. Is it like
Yes,
this?
yes.
Okay. And this private IP and public IP or like from which side?
So this private and public IP, you will understand. This is VPN 0 configuration.
Oh, yeah.
I will show you all this information. See,
Oh, yeah.
let me
Why
let
I
me
asking
show.
this private and public both are same IP, so that's okay.
See here. Yeah, means if you don't have different IP for private and public, this is lab environment. So that's why it is showing you same. But you can see here. See, I can go to my device, and here you can see that in my device, what's the IP I have over VPN 0. So I have two interface. One, I don't know at this moment which is for internet, which is for MPLS. So what we can do, we can go and check show run VPN 0 interface. Show run VPN 0 interface. Gig E0/1, right? So 0/1 having IP, this color is MPLS restrict. What is meaning of restrict? We will check. And then you have 0/2. So 2.62 belonging to internet. Okay. Now see here, this is MPLS interface. This is internet. Okay. Now if you go and check show tunnel stat, see here that source IP, this destination IP, this is your IPsec information, right? So IPsec source and destinations are these. Any doubt in this you can ask. Then I will come to the controller.
No, here this was not out.
This okay? Okay. Now if you check show control connections, now you can see that for control connection, this is my VSmart IP. This is my VSmart IP. This is my VSmart IP. Everything here is related to VSmart. How? Let me show you that. I log into one of the VSmart. So I can do VS, go to the still admin. I know that VSmart IP is 12.12.12.12. This is system IP, right? For one of the VSmart. Show interface description. See the IP. 198.181.12. Here you can see 198.1.12. This is for control connection. Please do not mix with IPsec. For IPsec, you have public facing IPs, source and destination. And obviously you need to know the TLOC information. What's the color? What's the system IP? What's the color? What's the encapsulation? Okay, this is encapsulation. But to form the control connection, like DTLS in this case, you don't need this public IPs. You just need to reach out to the controller, whatever place it has. Maybe it is behind firewall or somewhere. Maybe it will do some sort of NAT. Okay, this connection is different than this connection.
Ratnesh, here
Mm.
I'm seeing that the both IP is the same, like this private and the public IP.
Yeah, because in this lab it has only one IP, private and public. That's why
So there is a two V-Smart or only one V-Smart here?
two VS parts.
So each V-Smart is going to peering to each other, right? Means one is
Yeah,
the primary and one is the secondary.
yeah. So
But
this is
how they
also
will
one
Where you are
identify it?
logging?
is one of the hosted lab. It is.
Hmm.
Yeah,
And how they will identify that if both is having the same IP?
they have different system IP. One having 12.12.12, one having 22,
Okay,
22, 22.
okay. By system IP, they can differentiate to each other.
Yeah.
Okay.
And two
Okay, thanks.
transports are
Thanks.
there. Yeah, two transports are there. So one of the box, it is reaching to one of the device like this, this. The two tunnel is there with one edge, one VS Smart, one is 12.12.12, one is 22.22.22. That's why you can see four connection there. And this is nothing but VPN 0 IP, because again this is lab, so that's why you can see this information. Public and private IP are same, but in your infrastructure you'll find that this is different, this is different. Okay, and this IP, so suppose this is my IP, how this IP will reach this IP? 100% behind the scene there is NAT. Either this NAT V on VS Smart level, I think it will not understand IP. Some NAT will be there. It is not showing here, but you must have NAT there. So MP something will be there. So they are able to reach. I'll come and I will check these things later on.
One question here,
Yep.
Ratnesh. Yeah. What is the meaning of this CIR?
I will
Go,
cover it.
go.
Okay. I will cover it.
Oh,
Don't
this is the
worry.
interview questions, so that's why I'm asking.
Yeah. 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 This thing we have discussed earlier as well. Don't worry. I will cover it. Say chosen,
Okay,
installed,
installed.
resolved. If you see
Okay,
some sort of invalid means these things will come when we'll do our lab. It will come. You can say CIR and CR. So you may have two routes, but one you are installing. So that's why it's a CIR. Once is backup, we can think as a backup. So this is CR. If this will go lost, then it will become CIR.
okay, okay.
Okay.
And can you paste this thing in the chat, please?
Yeah, yeah, why not?
Thank you.
Okay. So we are very much done for today's session. We have covered the basics. Now what I'm going to cover in next class, let me quickly tell you about this. So we'll go and check the configuration. Next class we have to do one lab related to configuration and configuration template. I'll go and create something via the GUI because we have to learn about GUI. We'll go and understand about configuration and templates. And there are so many small things are there. We'll go and check that. And in other half, we'll go and check about the design as well, data center design and maybe branch design, etc. Okay. If you have any other question, feel free to ask. Let me stop the recording.